So hello again. Here is another example where I will show you how to use RSA data if you only know the public part of a key. So let's start it just like the example before, but then I will choose some value of P, some value of Q that you don't know, and from that I will publish a value of n, which is 303,632,003. Then, from the value of P and Q, I'm the only one to know, I will easily compute phi of n, which is still P minus 1 times Q minus 1, still secret. Then I can choose a value of the exponents, which would be 1,025,771. So this is the public key. Then on my side, still with unknown values from phi of n and e using the extended Euclid algorithm, I will compute the value of d. So I know p, I know q, I know phi of n and d. Of course, I've chosen real values, but I only publish the result as n and e. So perhaps you can try to find the value of p, q, then phi of n and d, but that's not the purpose of the exercise. So this is my public key. So if you want to send me some message, let's use it as before. For example, you want to send me a message which is m equal to 624,345. So that's a value which is clearly in the range that no one can use because n is so high compared to other examples. So if you want to do this calculation, it's always the same thing. The cipher message you would send me is m to the power of e modulo n, regardless of, let's say, if there are small or big numbers. This doesn't change. So the calculation to do would be the following one: to the power of e, which is 1,025,771, modulo this very big n. So actually, using the algorithm for quick modular exponentiation, you would get actually c, which would be equal to 64,318,488. Then on my side, getting this value, I would be able to calculate c to the power of d you don't know, modulo n, and actually I will get back to the value of n. So I've made the calculation, so you can trust that this is okay. So now to end this little video here, just as a user of someone's public key when you don't know the private value, that's the way you would handle the thing. Now, just if you want to check, actually here are the private values that have been used. Okay, P has been chosen as 16,000, sorry, 673. Q has been chosen as 18,211. Then phi of n is also a big number. It's 303,597,120. And from phi of n and e, it's quite easy. Actually, calculation have been done with little Python programs. So it's a few lines and the calculation is quite efficient. It's a matter of seconds. So D is also a huge exponent. 217,182,851. So actually, if I try to do the calculation of c to the power of d modulo n, actually, I get back to the original message.